2-1, right? First lesson in Unit 2. So let's see. What do you notice? What do you wonder? Okay, let's see here. I'm looking at, let's see, we got A, B, C, and D, these four, what looks like rectangles here. So I noticed four rectangles. Okay, what else do I notice? Well, I noticed that this one looks like it's blue. The one with the A in the middle looks like it's blue, and the rest are green. Let's see here. What else do I notice? This one, the blue one, doesn't have like the little prime symbols, the little apostrophes after all the letters, right? So maybe this one is the original. And then we can look at, let's see, what else do we notice here? Okay, well, if this was, how could I get this? If these are primes, how could I get this one to land on these? Well, if I look at B, it looks like if I just had like a line of reflection that was right here, right down the middle here, then Q would land on Q prime, R would land on R prime, S would land on S prime, and P would land on P prime if there was like a reflection, a line of reflection right here. Okay, that's another thing that I notice. Okay, let's see here. How about this one down here? Oh, let's see. Okay, actually, I'm just going to go around here. Let's see, B. So, and you know what? If I flipped this one, if I flipped A across to B, and it was in this position, if I had another line of reflection right here, I could just flip B down and it would land on D, I think. R would go to R prime, or R prime would land on R double prime, I guess. S would be S double prime P, right? So those would land on each other if there was a line of reflection going across here in between B and D. Oh, wait a minute. You know what I could also do? Check it out. I think that if I had like a point right here, right in the middle, and I use that as a center of rotation, I could actually take A and rotate it around 180 degrees and get it to land here, because the R would land on R prime, the Q would go all the way down here to Q prime, the P would go all the way around here to P prime, and the S would go all the way around here to S prime. And if you look, you can see that this would be a straight line through here from S to S prime, and it would go through that center point. Same thing with all of them, right? R to R prime, Q to Q prime, they all go through this center point right here. Okay, so let's look at this last one here. Let's see here. P. Oh, maybe I can just slide this one, right? Because P goes down to P prime and Q goes down to. Oh, wait a minute, no. Oh, that's messed up. Oh, that doesn't work, right? P can, if I slide this down, if I translate A down, I can put P down on P prime and S would go to S prime, but these two won't slide down. They have to be flipped. So this one's really messed up. Okay. So there's a lot of stuff that you could say that you notice here. So pick a couple of those things and put them in here. All right. Next. Okay. It says triangle ABC is congruent to triangle DEF. I'm going to blow this up a little bit here. There we go. Okay. Okay, so they already tell us that these two triangles are congruent. Now, we talked about corresponding parts, right? So C is the really pointy corner, and F is the really pointy corner. So C is the last letter in the statement, and F is the last letter in the statement. Those are corresponding parts. See, triangle ABC is congruent to, that's what that symbol means, triangle DEF. So C corresponds to F, A corresponds to D, right? That's the one that looks almost like a right angle, A and D, and E is B, and that's that one, okay? Find a sequence of rigid motions that takes triangle ABC to triangle DEF. Okay, so we remember that in order to get one triangle to land on another, if they are congruent, we go through a sequence, right? Usually it is translation to match two corresponding points, then a rotation of some sort, and then the third thing would be, if you need it, a reflection. Okay, so let's see. Let's just do this the easy way. So B and E are corresponding points. So I'm going to put those two together first. So translate triangle ABC using vector BE, and that will put B directly on point E. So we'll have this triangle sitting here. Okay, it'll be over here now. Okay, all right. Then let's see here. Then I would rotate. Okay, so what I'm going to do is, since B is over here, what I'm going to do is I'm going to rotate using that point that they now share, which would be E or B prime, which is going to be right here. I'm going to rotate this until C lands on F. Okay, so the triangle that's sort of over here, right, the ghost triangle, I'm going to rotate it until C lands on F. So that means that this angle right here, whatever angle this is going to be my angle of rotation. So it's going to be C prime EF is going to be the angle that I rotate by, and I'm going to rotate clockwise. So step one, translate triangle ABC using vector BE. That'll get that over there. And then second step, number 2, rotate triangle A prime, B prime, C prime using point E as the center of rotation. And I'm going to rotate clockwise using angle C prime E F. C. Wiley, settle down. Shh, 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 shh. That's my dog. All right. C prime E F, because C prime is going to be up here. Okay, so that will put those corners together. So now this edge, the two triangles are matched up along this edge, EF. And now since I still haven't matched them totally, that means I have to reflect them. So step 3 is going to be to reflect across side EF, and that will get this other triangle to land on top of the other one. Okay. All right. So what is the image of segment BC after that transformation? Okay, so where does BC end up? Okay, well, B we know is on E, and C we know is on F. So it's going to be EF, right? B is going to be on E, okay? And C is going to be on F, so it will be line segment EF. There we go. That was pretty easy. Okay, explain how you know those segments are congruent. Well, here's the thing. They told us that these two triangles were congruent, and BC is the corresponding part to EF. So how do I know those segments are congruent? Well, first of all, we're given that the two triangles are congruent. And second of all, BC and EF are corresponding parts. So corresponding parts of congruent triangles are congruent. All right. Justify that angle ABC is congruent to angle DEF. ABC is congruent to DEF. ABC is congruent to DEF. That's essentially the exact same thing, right? Same argument here, right? Angle, we're told that triangle ABC is congruent to triangle DEF, and angle ABC and angle DEF are corresponding parts, and corresponding parts of congruent figures are congruent. There you go. All right, so here they want us to they should have given us a different set of tools. I don't know why they gave us these tools, because here it doesn't allow us to do any sort of reflections. So I'm not sure why I'm not sure why this is the set of tools that they use. They should have given us the other set, because there's no reflection or anything in here. So I'm going to skip over that. Okay. All right. For each figure, draw additional line segments to divide the figure into two congruent polygons. I'm going to just drag this over so I can see all the parts of this. There we go. Okay. All right. For each figure, draw additional line segments to divide the figure into two congruent polygons. Label any new vertices and identify the corresponding vertices of the congruent polygons. Okay. Fair enough. Okay, so there's a bunch of ways I can do this, right? This shape can be split in ways that, well, let's start with this one. This one looks a little more reasonable. Draw line segments to divide the figures into two congruent polygons. Okay, so I'm going to do this. Draw a line segment from M to R. Ta-da! Done. Okay? All right? And so I can just translate this over and move it down, right? N would land on K, M would land on J, P would land on R, Q would land on S, right? Slide it over, slide it down, or just slide it diagonally until N matches K, right? That's one way I could do this. Let's see if we can do another way. How about this, right? Kind of a half an arrow, right? With this one, if I use this center point, I can just rotate 180 degrees, and P would land on J, Q would land on K, M would land on R, N would land on S. Okay, so I could just rotate that around. All right, let's look at another one. We go like this, and like, oops, almost like that. Okay, again, this is just a question of rotating 180 degrees around this center point, and again, P would land on J, Q would land on, let's see, K, R would land on M, and S would land on N. Okay, if I rotated this one going around this way at 180 degrees. All right, so that's that one. Let's see, I think that's, yeah. Okay, cool. So that's that. This one I think is the easiest right here. This is the one that jumps out at me, just looking at it. Although I don't know for sure that this one is the same as that one, but based on the fact that they're telling us that we can draw them, split them, then I think that all these edges are the same length. All right, how about this one? All right, let's look at our line tool. I say we draw one from A to B. And we've got this sort of arrowhead shape, and D, and again I'm just going to rotate this using this center point right here, the midpoint of AB as my center of rotation, and D spins around, lands on Z, F lands on G, L lands on E, and A would land on B and B would land on A, right? So that's one way we could do this. How about another way? Let's see. How about this one? Split it this way, right here. That looks like two kind of weird shapes, but they're going to match. Sort of like a squished sock or something. I don't know. So again, D would land on Z, B would land on A, E would land on L. Again, I'm just rotating around the center point of FG. And is there another one? Can I do another one? I think so. Let's try this one. From D to Z. All right. So again, this is, right, D lands on Z, G lands on F, E lands on L, B lands on A, rotating around this central point of this, whatever line segment we draw to split these in half. There we go. Okay. I just think that one's the easiest one to see. Okay, next. Use the applet below. Draw a triangle. Okay, I can draw a triangle. Use the polygon tool here. Draw a triangle. All right. Just doesn't tell me anything about the triangle, so I'm just going to draw a triangle. Okay. Find the midpoint of the longest side of my triangle. Well, I'm not sure which one's longer, so I'm going to make this one longer. And then I know that AB is definitely the longest one. Okay, find the midpoint. Well, they're going to give me this tool under the point menu for the midpoint. So I use the midpoint tool, and I just have to click on this edge here somewhere, and it'll tell me where the midpoint is. There it is. Okay. Rotate your triangle 180 degrees using the midpoint of the longest side, so using D as the center of the rotation. Okay, so I think this is the rotate around point tool. So I'm going to rotate this triangle, selecting the triangle in the center. Then I'm going to pick this D as my center of rotation. And they said to rotate it 180 degrees. Now they didn't say which direction because, as we remember, it doesn't matter whether you are rotating clockwise or counterclockwise if you're just rotating 180 degrees. Boom. Okay, great. So far, so good. Let me move this a little bit so I can get that away from the edge there. Okay. Label the corresponding parts and mark what must be congruent. Well, the corresponding parts are C and C prime and A prime and B prime and A, right? Because, let me see, let me move these out of the way. Can I move this? Yeah, there we go. There's A. All right, right? So A, B, and C, there's my original, and A prime, B prime, and C prime, there's, so A prime is the corresponding point to A, B prime is the corresponding point to B, and C prime is the corresponding point to C, which means that B prime, C prime is the same as B, C, and A prime, C prime is the same as A, C. And of course, this segment is the same as itself. Okay? Okay. What kind of quadrilateral have we formed? Okay. Well, if I look at this edge right here, AC. Now I've rotated this object 180 degrees. Let me expand that. Let me turn that into a line. Right there's. Oh, wait a minute. Let's go back 2 steps. Nope. Darn, they didn't let me keep the letters where I wanted them. Let me fix that. There we go. Okay. So now I've got this line going from A to C. Okay. So that's my original side. And when I rotate a line 180 degrees, I will either get the same exact line just flipped over if the point of reflection is, center of rotation is on the line. But if it's off the line, right, in this case, which is D, right, I rotated it around D, I'm going to end up over here. And let's just double check that, right? Rotate around point. I'm going to select the line. I'm going to pick D as my center point. And again, I'm going to change that to 180 degrees. And it should land right on A prime, C prime. Ta-da, it did. And we know from our previous lessons that when we rotate a line and the center of rotation is not on the line, we will get a parallel line. So the same thing can be said for side BC, right? If I take this side right here, BC, and I rotate that around 180 degrees around point D, because I rotated the whole triangle 180 degrees, so every side gets moved 180 degrees. It's going to end up here, and of course that's also a parallel side. So what kind of quadrilateral do I have? Well, the opposite sides are parallel, so that means it's a parallelogram. Okay? What is the definition of that quadrilateral type? Well, a parallelogram is a quadrilateral where opposite sides are parallel. Boom. Okay. Why must the quadrilateral you have fit the definition? Well, because when you rotate a line or a line segment 180 degrees around a point that is not on the line segment itself or not on the line, right, you will end up with a parallel line. So as a result, all the sides form parallel lines, except for this one, which lands on itself, which is actually a good example, right? So if you look at, oops, use line. So line segment AB, if we turn that into a line and we rotate it 180 degrees around point D, we're going to just land exactly where we are. Boom, right on ourselves, right on that line that was already there. Okay, so why must the quadrilateral you have fit the definition? Because any line that you rotate around a point that is not on the line, if you rotate it 180 degrees, you will end up with a parallel line. There you go. All right, so that was the walkthrough for this lesson. Move on to the practice.